told the freshman, and the freshman said like, yeah, and if it's because of like the freshman stage stuff, if there's too many no.
Alrighty, people. Oh, look what I did. I went to the wrong slide. All right. Continuing on from where we were at this morning. All right. So now we're going to take a solution like that where we found all the zeros and figure out what the graph is going to generally look like. Not exactly, generally. All right. So if I put down a graph here and go 1, 2, 3, 4, -1, -2, -3, -4. Now, where do I know this function is going to cross the graph at? At -1, at 0, and at 3. Okay, I know that because those are the zeros of my function. So that's where they're going to cross the x-axis. Because the leading coefficient is positive, where is it going to end? Positive. So it's going to look like this. It's going to look like this. It's going to look like this. Okay? Now, did I state exactly how far up or how far down we went? No. But, you know, with the larger space in between, you're going to go down a little bit more than you go up. But that's the general shape of what the curve is going to look like. Okay? What the function is going to look like. So there you go. All right. I'll talk about multiplicity here. I skipped over those 2 pages because it's complicated how they talk about it. Look at the powers. That is your multiplicity. Your powers is your multiplicity. So if we set this function equal to 0, we have -2 as a root and 1 as a root. Okay? -2 is a root with a multiplicity of 3. And 1 is a root with a multiplicity of 2. Okay? So it's a 5th degree function, but it's going to look a little different. So if we go -2 and 1. Okay? Now, leading coefficient, positive or negative? Positive. So it's going to come from up here somewhere. 1 is a root, -2 is a root. Now, because it has a multiplicity of 2, if it has an even power, an even multiplicity, Cheyenne, pay attention please. If it has an even multiplicity, it's going to bounce on the x-axis. It's not going to cross the x-axis. So we say that it's going to bounce. If it has an odd multiplicity, it's going to cross. So most of the time, roots have a multiplicity of 1, so it's going to cross. But if it's an even number, it's going to bounce. So in general, the graph is going to look like this, okay, because of the multiplicities. And you see how it looks, okay? Now, my graph could have been a little better because with a multiplicity of 3, it's going to flatten out a little bit. So I should have made mine flatten out and then cross. But, all right, you get the general gist. We're not going to talk about the intermediate value theorem. Discard. We are going to go to here and look at some of the problems that you're going to look at. What's the degree of this monomial right here? Not 3. 5. You add up all the powers. Okay? The leftmost zero is at what? This one is at 1. This one's -3. What's further left? -3. It has a multiplicity of 2. Okay. The rightmost zero is at 1. It has a multiplicity of 3. Okay. So it's going to bounce at -3. It's going to cross at 1. It's going to cross at 1 and bounce at -3. And since it's positive, it's going to end up. Okay. So bounce at -3, cross at 1. I think it's like B. I wonder what their magic word they want there is. Crosses and does not cross. All right. So here, since it is at 2, it's a multiplicity of 2, it does not cross. And then this one crosses. Okay? Oh, geez, the words were right there. Okay. What are the zeros of this function? How do I find the zeros? First, I factor out an x, and I get x squared minus 3x minus 4. And then I factor x minus 4, x plus 1. And so 0, 4, and -1 are my zeros. Okay? Find the zeros, you factor. If you can't factor, you do the quadratic formula. Okay? Now, these are the zeros. How do I find my function? Well, what you can do, x minus 2, or -2 gives me an x plus 2. 3 gives me an x minus 3. -6 gives me x plus 6. Okay? FOIL these two, x squared minus, or plus 3x minus 18. And then double distribute. X cubed plus 3x squared minus 18x, and then distribute the 2, plus 2x squared plus 6x minus 36. So it's x cubed plus 5x squared minus 12x minus 36. Okay, so what goes in here is the 5. Okay, so, and if we have square roots, they always come in conjugate pairs. So x minus the square root of 6, x plus the square root of 6. What happens when we FOIL conjugates? The middle term does what? Cancels. So it's x squared minus 6. And then you take it times x minus 3, FOIL, you get one of those. Okay, and then we'll have a problem involving speed and distance. Okay, so I'm going to grab my graphing calculator here. Boom. Maybe I'll move it over here. Okay, so it wouldn't be a bad idea to get out your graphing calculators to do this with me. I know some of you are in your food coma right now. It's really hard to listen to me because you're full. Your belly's full, nice and warm. Mr. Birchbach's voice is soothing. It wants to, you want to fall asleep, but you don't get to. All right. So if we have a table of values, okay, then we go list. No, not list, stat. Stat, and then edit our list. Okay, it's kind of a list of values. Okay, and then I'll punch in 10, 20, 30, 40, and 50. And then on the next hand column, right column, I'll go 20.9, 35.5, 80.5, 129.5, and 185.5. Okay? So you have list 1 and list 2. Okay? So what we're going to do is plot the points. Okay? So instead of graphing the points, we're going to plot the points. So we'll go second, y equals. And we're going to turn our plots on. So I'm going to push enter at this point. So it's going to look like that. I'm going to turn them on, and I want the dots, not anything else. Okay? So I'm going to push on the dots, the first one, and I'm going to compare list 1 and list 2 because that's where I put my data. Is everybody good with this point? Okay? Second, plots, go to the first one, and we're going to turn it on and have these highlighted. Okay? Now, here's the magic that happens. We're going to push the word zoom, and then we're going to push number 9 for zoom stat. And I got an extra function in there somewhere, graphed, but we'll get rid of that later. But your function looks like this. So you can tell which graph it is. It is obviously graph letter D. Okay? Now, we want a quadratic regression model. Well, the calculator figures out our quadratic regression model for us. How does it do us? Well, you click Stat, and then you go over to Calc. So right arrow once to Calc. Okay? And we want a quadratic regression. Well, what number do you think that is? 5. So you click on 5. The first one is L1. The second one is L2. We're going to store the regression equation. Okay? Where are we going to store it? Well, we're going to store it into Y1. How do I get Y1? I'm going to click the word vars. It's right next to program here. Right by clear. Vars. I want my Y vars, so I'm going to arrow over to the right to Y vars and function. And I want to store it into Y1. Okay? So basically, I'm storing my regression equation into Y1. And I'm going to calculate and hit enter. And it gives me this. And you're going, well, what is that? Well, it's one of these equations. And if you actually go to Y equals, there's your equation. And we stored it into Y1. Whoops. We stored it into Y1. So it's sitting right there for us. Okay? So it is choice A. So if I hit graph now this time, we replaced whatever that other graph was that I had in there with this one. See how the line goes through there just perfectly? Well, almost perfectly. So it says choose which one it is. Well, it's D. Okay. Now, this is where it becomes important. This is why you've been doing this on your calculator with me and following along instead of just sitting there like a lump on a log, just watching, not learning anything. Okay. Now we're supposed to figure out predict the stopping distance for a vehicle traveling 23 miles per hour. So the speed is our X. So we're going to trace on the graph to 23. So we're going to click trace. And if I trace right now, see how I'm on 10? If I go to the right, I'm on 20. I'm on the dots. I don't want to be on the dots. I want to be on the line. So I'm going to push either my down arrow or my up arrow. Now I'm on my line. So if I go left or right, see how I'm actually on my line? Where do I want to trace to? Well, how many miles per hour? 23. So I click in 23 and hit enter. And I get 51.394. So my stopping distance will be 51.39 feet. Okay? Now, where will my stop? How fast am I driving if my stopping distance is 100 feet? So on my graph, I just arrow over till I get to 100. Now, you might say, well, can't you just search for it like you did the X value? And no, you can't really search for it. I mean, there's ways of finding exactly 100. Okay? One way of finding exactly 100 is to go to Y equals and make Y2 equal to 100. We want our Y value equal to 100. And then if we click graph, what do you think I'll do next to find the Y value that's equal to 100? Find the intersection of those two. Second, trace. we're going to find where they intersect. So I'm really close there. Enter, enter. So my intersection is at 34.86. My intersection is at 34.86. That's how fast the car is going to have a stopping speed of 100 feet. Okay? So that's what you're basically going to do. 6 problems, won't take as long as the first assignment. Here we go.